And I am doing this project with the help of my other two teammates. Actually, my project is related to Bldc motor, and the title of our project is Digital Control Strategy for Four-Corner Operation of Three-Phase Bldc motor using Fuzzy Logic.
Well, actually, brushless DC motor drives are becoming more popular in industrial and traction applications. So this makes the control of BLDC motor in all the four quadrants very vital. This project deals with the digital control of three-phase BLDC motor. The motor is controlled in all the four quadrants without any loss of power. In fact, energy is conserved during the regenerative period. The Fpga which we are using in this project is very advantageous over controllers as it uses parallel operation to achieve precise control. Description. The DC voltage source is applied to the inverter circuit. Inverter converts the DC voltage to three-phase AC voltage. The inverter output is connected to the three-phase BLDC motor. In three-phase inverter pulses are generated from Fpga. Output of the Fpga pulses are given to the optocoupler. Output of the optocoupler pulses is inverted pulses of the input. But we want same pulse generated from the Fpga. That's the reason for we are choosing NOT gate IC is introduced in output of the optocoupler, and then the output of the NOT gate is given to the input of the driver IC. The driver IC nothing but high stage buffer IC, and the output are given to the three-phase converter switch as MOSFET or IGBT. Pulse signals from the BLDC motor is converted to the buffer circuit, and the buffer circuit is used to remove the harmonics in the Hall signals. Output of the buffer circuit is converted to the capture signals of the controller. The controller reads the captures and the corresponding pulses are generated in Fpga that are fed to the inverter circuit. The input AC supply is given to the step-down transformers. The step-down transformer step-downs the input voltage from 230 to 12 volt and 18 volt respectively. After that, the bridge rectifiers are used to convert the AC voltage to the DC voltage. These are the three capacitors are used for smoothing of the voltage and remove the unwanted disturbance occurs. And these are the two voltage regulators is used to regulate the input voltage from 9 volt to 5 volt and 18 volt to 12 volt is given. 5 volt is given to the Fpga and 12 volt is given to the inverter circuit and the relay circuit.
Now I'll explain you the part of our inverter circuit which is being fed from this supply directly to our inverter circuit. What actually is included is these are the optocoupler ICs, and this is a NOT gate ICs, and this is a driver gate ICs, and these are the 6 MOSFETs which I am here using for our project. What actually happens is directly the signals are fed from the Fpga directly to our inverter circuit, and this optocoupler acts as a barrier between the Fpga and our inverter circuit, and further that these signals are being provided to our NOT gate ICs as the output which is being derived from the output that optocoupler are inverted. So in order to get our original waveforms, we are using this NOT gate ICs, and this is fed directly to the driver ICs which are being supplied to our MOSFETs, and this is a snubber circuit where we will try to protect our MOSFET ICs.